Welcome to DSMA 8 Linear Equations. Before we get started with lecture today, what I want to go over is the difference between an expression versus an equation. So when you're looking at an expression, the instructions will say simplify. Now, simplify means to perform order of operations, which we know as PEMDAS. Clear what's inside of our parentheses. Next, we look for exponents. After that, we look for multiplying or dividing from left to right, looking at your expressions. And then finally, we will do the add and subtract. So we simplify expressions and we solve equations. Now, when we take a look at an equation will have an equal sign on it. But to start, what you do is you perform order of operations on the left side of the equation. So we're going to do PEMDAS. There's our equal sign, and then you perform order of operations on the right-hand side. An example of an expression may be something like this: 5x minus 2 minus 3x plus 4. Whereas the equation may look like 5x minus 2 is equal to 3x plus 4. Another thing to consider before we get started in solving equations is just being able to identify the difference between like terms and unlike terms. So like terms have the same variables, raised to the same power or degree. So in this case, we may have something that looks like 3x squared and negative 17x squared. Because they both have the x to the second power, those are considered like terms. When you have like terms and can identify them, you can add or subtract them if they're on the same side of the equation or if they are in an expression. Unlike terms may be something like this. So in this case, we have 5x and we have negative 11. They do not both have the same variable raised to the same power. We cannot do anything with the 5 and the minus 11 or negative 11. They have to stay separate. So let's get started on our lecture. As mentioned, we're going to go over linear equations today. And this document can be found in my math lab, Course Tools, Document Sharing. These are the same slides that we would go over in a class lecture. All right, the second slide here gives you a demonstration of some variety of ways to solve an equation. Take a look at that and decide what helps you avoid mistakes and what is easier to learn for you. There's just different ways to set these up. All right, let's go ahead and start with our first problem. All right, so our first problem says solve the equation. 9x plus 48 is equal to 2x minus 22. So we have identified that as an equation, and your goal in an equation is to isolate x by itself. So we want x equals a number at the end of the day. When we take a look at this equation going from left to right here, notice that on the left-hand side, there are no like terms. 9x plus 48 are unlike terms, so we cannot do anything here. On the right-hand side, we have 2x minus 22. Those again are unlike terms. We cannot do anything here. So at this point, PEMDAS equals PEMDAS has already been done for us. The next step, what we're going to do is to get x's on one side, numbers on the opposite side. So what I like to do is I like to look at my variable terms first. I see that I have a 9x on the left side and I have a 2x on the right side. What I am choosing to do is to work with the 2x and to move it to the opposite side of the equation. You may choose whichever term you would like to. You can choose the 9x, you can choose the 48, or the negative 22. But for this purpose, I'm going to stick with my favorite, looking at my variables first and moving the smaller variable. So the opposite of 2x is negative 2x or subtract 2x. So what I'm doing is taking this 2x minus 2x, which will cause that to go to 0, and subtracting it to the opposite side of the equation. So what you remember is that you have an equal sign here. When you have a order of operations being performed, you have to move to the opposite side of the equation. All right, so this is now leaving me with 9x minus 2x. 9x minus 2x will give me 7x. I still have my 48 on the left-hand side equals to, and only a negative 22 remaining on that right side. So now we have our x's on the left-hand side of our equation. Our next step is to move the number or the constant over to the right-hand side. So we're going to look at this positive 48, and we're going to subtract it. As we subtract 48 from both sides, it removes the 48 on the left side. This now leaves me with 7x on the left equal to, and a negative 70 on the right-hand side. We are not quite done yet. What we need to do is to remove that 7 on the left side that is with the x. So if you take a look on the left-hand side here, 7x is a multiplication. The opposite of multiply is to divide. So I will divide this left-hand side by 7, divide the right-hand side by 7. 7 divided by 7 is 1. 1 times x leaves x. Negative 70 divided by 7 is negative 10. And this is called our solution. So once again, your goal is to isolate x on one side of the equation. It does not matter if you want your x's on the left side or the right side. Since we are dealing with the same equation, you will get the same answer as I did. One of the things we can do also is to run a check to make sure that we have the right answer. When you do this, what you want to do is to place our solution, negative 10, into the original equation. So I'm taking this original equation, 9x plus 48 is equal to 2x minus 22. I'm going to replace the x's with a negative 10. I'm going to put a question mark here because we're checking to see if the left side will equal the right side when we're done. All right, going from left to right, 9 times negative 10 is negative 90 plus 48 equal to, and on the right side I have 2 times negative 10. Whoops, there we go, minus 22. All right, so on the left-hand side, negative 90 plus 48. And you can quickly work that in your calculator. You should get a negative 42. And on the right-hand side, a negative 20 minus 22 is a negative 42. So this works. It's saying that negative 10, when substituted into the original equation, gives me a true result. So indeed, our solution is negative 10. So you may have noticed I spent a little extra time on this problem because I want to make sure that you've learned your steps. As we move along the slides, I'll go a little bit quicker. All right, so this was just a check. Let's look at our next problem. All right, this one is asking us for us to solve the equation. So I have negative 4 plus 10 is equal to 17x minus 5 minus 16x. All right, on the left-hand side, we need to perform order of operations. Negative 4 plus 10 will give you 6. Remember, those are considered like terms. And then on the right-hand side, we also have like terms, 17x minus 16x. 17x minus 16x is x, and I will bring down this negative 5. That leaves me 6 is equal to x minus 5. The next thing is to get the x by itself. So I will do the opposite of negative 5 and add 5. What you do to one side of the equation, you do to the opposite side. Remember, we're going to add vertically if you want to see it this way. 6 plus 5 is 11, equal sign, and then x. And this is my solution. So x equals 11. And once again, you can check it the same way we did in the last problem. All right, so what we did here is we combined like terms first on both sides of our equation. And then we did what's called the addition property of equality. We added the opposite to the opposite side to finish solving. All right, here is our next problem. Minus 15x minus 20 is equal to 13x plus 50. As you heard earlier, I like to work with my variables first. So I'm taking a look at the negative 15x and I'm looking at the negative 13x. And I am going to move my smaller number. So negative 15 is smaller than negative 13. So the opposite of negative 15 is a positive 15x. What I do to one side, I will do to the opposite side. So in this case, I'm actually moving my x's to the right-hand side of my equation. All right, this leaves me negative 20 on the left equals to negative 13x plus 15x, or you can say it vice versa, 15x minus 13x is 2x. Now that we have all our variables condensed over to the right-hand side of our equation, we will move our constant or our numbers over to the left side. So I'm focusing on this positive 50 that needs to be moved over to the left side of the equation. To move it, we do the opposite. The opposite of 50 is negative 50. Perform this operation on both sides of your equation. and that will give us negative 70 is equal to 2x. Next, again, we will undo this multiplication on the right-hand side, 2 times x, with a division. Divide by 2. Divide both sides of the equation by 2. This divides out the 2 on the right-hand side, leaving me just x. And negative 70 divided by 2 is negative 35. So each problem is unique. If you noticed on this one, we went straight to adding the opposite to the opposite side. That is called the addition property of equality. So we added a positive 15x to both sides. We performed that property twice. So we did the addition property again on this second step by subtracting 50 to both sides of our equation. And this last step, when we multiply or divide by a number, that's called the multiplication property of equality. All right, let's keep going. This is slide number 7, and we have a lovely fraction. So this says negative 10 minus a negative 41 is equal to x divided by 5. Now I know you all are looking at that fraction. Please don't worry about it. First thing we need to do is order of operation. Remember, it's PEMDAS on the left equals PEMDAS on the right. So the first step we need to do is rewrite that left-hand side. Now the left-hand side, I have a negative and a negative 41. That is stated as the opposite of negative 41. Or you can see this as a negative times a negative, which will make that positive. So let's do a rewrite. Negative 10 plus 41 is equal to x divided by 5. Now we need to still do order of operations on that left side. Negative 10 plus 41 becomes 31 is equal to x divided by 5. Now that we have our variable term, the x divided by 5 by itself, we have to focus on removing that 5 from the denominator. We do this, since it said divide by 5, the opposite is to multiply by 5. So the opposite of divide is multiply. I'm multiplying by 5 on the right-hand side, so I need to multiply the left-hand side also by 5. This will give me an answer of 155 is equal to x. So what happens here is these 5's divide out, leaving you 1. And 1 times x is x. All right, a few more slides to go. You're doing great. And let's take a look at this next one. It is set up just a tad bit differently. We have 5 parentheses, that means times, y minus 2 close parentheses is equal to 2y minus 10. All right, we're going to take that left-hand side, 5 times y minus 2. I'm going to take it over here to the left side of the screen, and we're going to work this differently. The process that we have to use here is called distributing. Whenever you see a number in front of the parentheses, what happens is we have to multiply every term inside the parentheses by that value. So I'm going to write down what I see inside the parentheses, and I'm going to distribute the 5 to each one of those by multiplying. So I have a 5 times y, and over here I have to do multiplied by 5. Everyone gets multiplied by 5. So 5 times y just becomes 5y. And there's my minus sign, and 2 times 5 is 10. So 5y minus 10 is the result after distributing. So going back up to my original equation, 5 times y is 5y. 5 times that negative 2 gives me negative 10. The right-hand side, there is nothing that we need to do. It's already in PEMDAS order. So I'm going to focus on my variable terms and move my smaller y value, which happens to be the 2y. So positive 2y, the opposite of positive 2y is negative 2y. I'm just going to add vertically. 5y minus 2y is equal to 3y. So you're basically focusing on the coefficients or the numbers in front. 5 minus 2 gives you 3. Bring down the minus 10 on the left and equal to negative 10 on the right. You have your variable term on the left. Now it's time to move the constant term over to the right side. So since I want to move this negative 10 over to the right hand side, I have to perform the opposite, which is add. We will add 10 to both sides. When we do so, we end up with 3y is now equal to 0. Negative 10 plus 10 is 0. Keep your equation going so that you don't accidentally end up with just 3y and you forget your equal sign. That happens a lot with students. The next thing you want to do is to multiply 3 times y. We have to perform the opposite by dividing both sides by 3. 3 divided by 3 is 1. 1 times y is y. 0 divided by 3 is 0. So our answer or solution will be 0. All right, so let's back up on this one more time. What we did first was we did the distributing property, 5 times y, 5 times negative 2. We came up with 5y minus 10. Rewrote the right-hand side. Now we're trying to get y's on one side of our equation, so we did the opposite of 2y by subtracting 2y. What we do to one side, we do to the opposite side. Now we're combining like terms again. 5y minus 2y gives us 3y. Bring down the minus 10, and we have only minus 10 on the right-hand side. To get rid of the negative 10 on the left side, we have to do the opposite by adding 10. We add 10 to both sides, we end up with 0. 3y equals 0. To get rid of the 3, we have to divide by 3 on both sides of our equation to yield a solution of y equals 0. All right, next problem. And it takes practice with these, so keep practicing. Just remember, PEMDAS equals PEMDAS. Then we will add or subtract to the opposite side. And lastly, we will multiply or divide to find that final solution. So these are z's right here. Let me put a little crisscross there so you know those are z's and not the number 2. All right, so 14 plus 7 times z minus 2 is equal to 6z plus 1. So the first thing we need to do here is to distribute on the left-hand side. We want to take this 7 times z and 7 times negative 2. Everything else will remain the same. So here is 14 plus 7 times z is 7z. 7 times negative 2 is negative 14. And let's keep rewriting. Your next step on here is to combine like terms. So I notice that we have a 14 and a minus 14 on the left-hand side. The right side are unlike terms, so there's nothing to do. So 14 minus 14 is 0, which leaves me 7z is equal to 6z plus 1. So this time we only have one constant term on the right-hand side with the number 1. So I'm going to leave that number 1 right there. Take this 6z and bring it to the opposite side. To bring it to the opposite side, we must subtract it. And when we subtract, 7z minus 6z leaves us z equals to 1. And this again, z equals 1 is our solution. And you can check this by substituting the number 1 in for z into the original equation. All right, so let's take a look at this problem. It says translate the following sentence into an equation, then solve the equation. So we need to translate into an equation first, then solve it. It says the sum of 5, 8, and a number amounts to 19. Find the number. And it does say in the instructions in the blue region here, it says type an equation using x as the variable. Do not simplify. So we're going to use x as the variable. So I'm going to go over here and define that. The number is x. We'll take a look at our original equation. It says sum. Sum means to add. So that means we're going to add. Think of every comma as a plus sign. Plus sign 5 plus 8 plus a number which is x. Amounts to is the same as is 19. So this leaves me with 5 plus 8 plus x equals 19. So this is the equation we would add into my math lab. Just like that. Do not add the 5 plus the 8 because the instructions clarify. It says do not simplify. That means do not do order of operations. Our next step is to then solve the equation. So when I take a look at the equation now, I will simplify. I have 5 plus 8, and that will give me 13 plus x equals to 19. Let's see if I can get that plus sign to look a little better. All right, next we need to get x by itself, so I'm going to take that 13 and bring it over to the opposite side by subtracting 13. And x is equal to 6. So the solution would be x equals 6. So this is the answer to the second part, and this is the answer to the first part. Translate into a sentence, into an equation, and then solve. All right, the next slide gives us a little more of an application problem. It says brand A has a recognition value worth $47 billion, more than brand B. brand A has $47 billion more than brand B. It says if the total value of these two brands is $113 billion, find the value of each of the brands. So what I'm understanding here is that, let me highlight a little bit on here. Brand A has $47 billion more than, that means a plus sign right here, more than brand B. And it says the total value of the two brands is $113 billion. So using this information, I'm going to slowly set up an equation so that I can solve this. So my understanding is brand A plus brand B has a total worth of $113 billion. Now we don't need to write all the zeros with the billions because you can see from the insertion of the answer, the billion is already listed on there. All right, now let's go back to that first equation. Brand A has $47 billion more than brand B. So I'm going to rewrite brand A. Now insert it right here. Brand A has $47 billion more than brand B. And I'm going to have my rest of the equation remain the same. All right, now you have an equation that is 47 plus B equals 113. Remember, PEMDAS is equal to PEMDAS. So we're going to add the two B's together, and that will leave us 47 plus 2B is equal to 113. We want to get B by itself, so I need to subtract 47 from both sides of my equation. That leaves me 2B is equal to 66. To solve for B, I need to divide both sides by 2. 2 divided by 2 is 1. And 1 times B is just B. So brand B has $33 billion. That's how much it's worth. So you have two ways to finish the next part. We know brand B is now $33 billion. And if you recall, brand A is equal to 47 plus B. So we can insert the $33 billion in place for that letter B, and we will get $80 billion. Or you can do it a different way. You know the total for both companies, their brands, are $113 billion. If we subtract brand B from that, we will also get $80 billion, which is the remaining left for brand A. So brand A has $80 billion and brand B has $33 billion. Our final slide asks us to write a sentence as an equation. Use x to represent a number. The product of 2 and the sum of -3 and a number is -25. Choose the correct answer below. So it wants us to translate this into an equation. So we have to find out that our keywords are product. Product means to multiply, and sum means to add. And what I do is I look for the and that falls, the word and, that falls closest to the word product there. So my interpretation at this point, the product of means I'm going to multiply two items. So I have 2 times something. All right, 2 times something. And that something is going to be the sum. And I'm doing the sum of -3. Again, I'm looking for the and. This is where my plus sign would go. So the sum of -3 and a number, which is x, means equal -25. And then we'll look through our options A, B, C, or D and find what option works best. And that looks like that we have option A. So once again, let me write this just a little differently to get you started. We did the product of 2 times the sum. So I kind of leave that as a shell to fill into. So that's how I would start out, as 2 times the sum. And then fill in the sum portion of it and finish out the equal sign. Now, it didn't ask us to solve this, but let's go ahead and solve it and see what happens. First thing we need to do is to distribute, and 2 times -3 would give us -6. 2 times x, get a plus 2x, equal to -25. Slowly get x by itself. I could add 6 to both sides of my equation, and that will leave me 2x is equal to -19. Now to undo this multiplication with the 2x, I will divide by 2, divide by 2. And that leaves me x is equal to -19/2. Now on my math lab, what you want to do is read the instructions. If it ever has solve and you end up with a fraction, it will say enter an integer or a simplified fraction. So since 19 and 2 have no other common factors, you would leave that as a -19/2 for your answer. If my math lab wants a decimal, it will tell you to enter a decimal form. If it wants a mixed number, it will also ask you for that mixed number. But for the most part, you're going to see enter an integer or a simplified fraction. So this would be the final solution. And this is the end of DSMA 8.